Hello everyone. I've had a few questions about this machine. This is a Gorton pantograph made back in the 1930s. I believe the last year they made them. This one is a 3U model built in Racine, Wisconsin. And the last year they made these was 1939 or 1940. This one I had purchased from a gentleman for about $200. And he didn't have any belts, and I just got these belts from McMaster-Carr. One is 84 inches, the other one's 54 inches, not too expensive. The electric motor needed to be oiled, but it did have a heck of a noise when I was running it. These two pulleys up here, the one on the right is nice and tight, but the one on the left, let me see if I can get this in view. See that movement? Now I just have a punch sitting in here holding it up because I drove out the pin so I could remove the pulley and take a look at it. And what these are, they're made out of a phenolic resin, and inside here there's two bronze bushings. So obviously the bronze bushing wore out and it's time to replace it. So now with the pulley out, we can see the phenolic pulley, and we have two bronze bushings in here, one on the left and one on the right. If we look closely, if I can get it to focus, see that crack right there? That's the damage to this little bronze bushing. And I didn't have any bronze in stock. I did have some 360 brass. The brass isn't as lubricating as bronze is. This 360 brass, is about 60% copper, 37% zinc, and about 3% lead. So got some 660 bronze. This 660 bronze is mostly copper with a high lead content, also with some tin in it. The bronze is pretty good hardness. It's a good bearing material. General use bronze, very machinable, ductile. Where the brass has got some good strength to it, and it's pretty corrosion resistant. So we're going to be using the 660 bronze to machine up one of these little bushings. And also this, I wanted to make a new wheel, but I think I'll hold off on that. This wheel is still in pretty good shape. I'm just going to true up this hole because with this damage, this did get a little bit of a taper to it. So we're going to straighten that out and make a new bronze bushing. So for this particular operation, I'm probably going to want to get this hole to a diameter of about 0.310. And I was looking at my high-speed steel bits, and I really don't feel like sitting at the grinder for a couple hours. But what I do have is a broken, or at one point was broken, end mill that's been ground down. And for you shop guys out there, for you home gamers, you're going to break stuff. It's just going to happen. You're going to dull end mills out, and how many of us, have the means to sharpen them? But that doesn't mean you should throw away your high-speed steel. You should probably hold on to it, because in instances just like this, it can come in handy for doing little small hole boring applications like this. So here's the setup. I have the phenolic pulley and an independent 4-jaw chuck, and I've got it dialed into a little under 1,000th. Although because of the damage, there's no telling that this hole is true. So you just got to get it as close as possible. And then we're going to take this bore to a diameter of 0.310, that's what we're shooting for. And then we'll make a bronze bushing for it. So for the home hobbyist that's a little bit new to this game, it's always nice to make yourself up a lathe height tool. Just spin it out of aluminum. At least that's what I did. And if you're using high-speed steel and it wears out on you, you need to resharpen it. You can just throw this up and then check the height of your cutting bit and make sure that it's on center. That's a little neat tip or trick that you can use at home to quickly gauge your height of your cutting tool. So we just got done cutting the bore to true it up, and unfortunately 0.310 wasn't attainable. We had to go up to 0.329 for that bore. It's got a really nice feel to it. If I had to guess its actual depth, 330 will fit in there just a little bit, but it's just a hair too tight. This 329 is almost exactly where it is. I'd guess 0.3295. But anyhow, so that's our new diameter that we're going to shoot for the bronze bushing. One more quick footnote: if you don't have money falling out of your back pocket, like most of us don't, and you can't buy a pin gauge set, a cheap Chinese drill bit set can get the job done. It's not the most accurate way of doing it, but you can use it as a pin gauge set. Of course, I'd probably recommend figuring out, the actual diameter of these, because they can vary. But it's an easy and cheap way to find out the bore that you're shooting for when you're making parts in the shop. And there was a time I had no money to my name, and that's the way I got some things done to achieve the accuracy that I needed. So we have our bronze rod sitting in the forge-jaw chuck. The diameter is about 0.550, and what we're shooting for is 0.3295 for an outside diameter and 0.250 for the inside diameter for our bronze bushing. And I'm not really a safety Sally or anything, guys, but this does have a high content of lead, so wearing a respirator might not be such a bad idea. I know I've probably burnt out my 9 lives being a young man, but that doesn't mean you have to inhale a bunch of lead. Anyhow, let's get cutting. So now we have the outer diameter to 0.3305, and we were shooting for 3295, I believe, but I just decided to do a test fit, and it's going on there just good enough. You want a little bit of a tight fit on this because you want it to stay inside the pulley, so I believe that we're probably going to leave it like that. I might polish it down just a little bit, maybe take off half thou. But right now I'm going to start doing the inside diameter. So we just about have this part where we want it. I was going to use a drill bit to do our inside diameter cut, although that wasn't working out. There's brass and bronze, they're very gummy materials, and they want to grab your cutting tool and draw it in, especially in milling procedures. But using a centering drill bit or a starter drill bit was exactly what we needed to punch that 1/4 inch inside diameter hole. And coming back to the drill bit had about 2.5 3 inches of overhang, and the brass was just sitting there causing one heck of a vibration. So using a more rigid tool setup is exactly what we needed to get that hole punched through. Now all we have to do now is part the bronze and then put her into the pulley. So here's our bushing inside the pulley, and I'll bring it over to the arbor press and get it pressed in flush with the rest of the pulley, and then throw it back on the Gorton pantograph. Well, now we have the pulley installed back in the Gorton pantograph, and just moving it with my hand, it sounds amazing. A lot better than it was. So that's just about it, the repair on the Gorton pantograph. If you like this video, like, share, subscribe, give it a thumbs up, and we'll see you next time.